Welcome again, guys. This is Tutoring Center. Today we are going to be looking at very interesting stuff. The fastest way to simplify I to the x, where x is a real number. Actually, it doesn't really matter what the index or the exponent is. If you have good foundations in indices and logarithms and sets, and you have good simplification skills, you can manage any power that comes. It doesn't matter the number base. Okay, before we get into the main issue of today, which is simplifying I to any power x, let's look at a little bit of background on imaginary numbers. So what if I ask you to find the square root of -4 on unless you are a high school student or above, that because the number systems taught below the high school level cannot accommodate, do not have any number that when you square it, the answer is a negative number. But with imaginary numbers, it is defined that the square root of -1 is equal to a certain I, and so finding the square root of -4 now becomes a piece of cake, because square root of a times the square root of b is equal to the square root of ab, square root of ab, like that. This therefore means that root of -1 times, oh, that didn't come out well. So the root of -1 times 4 root of -1 times 4 is going to be equal to the square root of -1 times the square root of 4, and therefore that is the square root of -1 times 2, and we know that the square root of -1, by the definition I just gave, is I. So therefore means that the square root of -4 is equal to 2I. Okay, I just wanted to put a little bit of foundation. Okay, now let's look at the definition of an imaginary number. It's one that is expressed in the form bi, where b is a real number and I is equal to root of -1. Okay, imaginary numbers form part of complex numbers which are expressed as a plus bi, where a is a real part and b is the imaginary part. Okay, let's look at a few things that you should just know offhand before you'll be able to simplify I to any power in seconds, in a matter of seconds. And this is very useful because these questions are a part and parcel of paper 1 type questions, so they usually can be paper 1, so you want to maximize as much time as possible, and it is also very applicable in papers 2 of the GCE examination. So we know this already. I is equal to the root of -1. I squared is -1. That is because I root of -1, all that squared, is equal to the root of -1 times the root of -1, which is equal to -1. As simple as that. The third one is that I cube is -1. If we know that I squared is -1, it means that I squared times I, so I squared times I is the same as I cube, and I squared is -1 times I. That therefore means I cube is equal to -I. This is actually I, so you don't get confused. Okay, we move on. I to the power 4 is equal to 1. This is simple, right? Because I squared is -1, it means we have I squared, all that squared. So -1, which is I squared is equal to +1. Yeah, we need to know this. Okay, there's also something we need to know. We need to know that -1 to the power 2n, 2n is the mathematical representation of an even number, is equal to, will always give you +1. So -1 to an even number will always be a positive. -1 to an even number will always be a +1, and -1 to an odd number, the mathematical representation for an odd number is 2n minus 1, because if you subtract 1 from any even number, you get an odd number. It will always be negative 1. So we have to know this. So negative 1 to an even number will be positive 1, and negative 1 to an odd number will be negative 1. Okay, so let's move on. Now we saw for negative 1 to the power an even number and negative 1 to the power an odd number. Now this is now time for the I itself. So that is root of negative 1. Now I to the power an even number, that is I to the power 2n, will always be either a plus or a minus 1. So we will not know for sure, and unless we go further, and that's what this video is all about. And I to the power 2n minus 1 will always give us either a positive or negative I. Okay, with that basis, that is all we need to know to be able to simplify things as fast as possible. This is just basic indices to remind us that a to the power x times y is equal to a to the power xy, and root a times root b is equal to root ab. We have already seen this at the beginning of the video. Okay, now let's look at some examples. Now, looking at some examples, let's try with an even I to the power an even number. Let's just say maybe 206. It doesn't matter how big the number is, it doesn't matter how small it is, this will always work. And so the method to do for to go for even numbers to simplify easily is to first factor I squared. We know that I squared is what? Negative 1. So if we have factored I squared, what is left out of this bracket is 103. So 2 times 103 will give us 206. We know that I squared is negative 1. So it means we have negative 1 to the power 103. What is 103? 103 is a number of the form 2n minus 1, which is equal to an odd number. It therefore means I to the power 206 is equal to negative 1. Simple, right? Simple as that. Now let's go further in the proceedings and let's examine say I told you it doesn't matter how big or small. Let's examine I to the power 26. This is a small number, right? So we have I to the power, we say for even numbers, even powers in the even indexes of I, we factor out 2 first. We factor out I squared, and then what is left out here? 13 is left out. So I squared is negative 1. Negative 1 to the power 13. 13 is an odd number. It therefore means that it therefore means I to the power 26 is equal to a negative 1. Okay, now so far we have seen for negative 1. Now let's see for positive 1. Now what will give us positive 1? Let's take I to the power, maybe I to the power 20. I to the power 24. I to the power 24. That 24 doesn't really look good. I to the power 24. So what we do first is that we factor out I squared as we earlier did, because it is an even number, and what is left out is 12. 12 is an even number of the form 2, even numbers of the form 2n, which is even. It therefore means that negative 1, which is I squared, to the power an even number, which is 12, is equal to a positive 1. It therefore means I to the power 24 is equal to negative 1 to the power 12 is equal to a positive 1. It therefore means I to the power 24 is equal to positive 1. Okay, now having done with that, let's look at now maybe let's see now for odd numbers. Okay, odd powers of I. So let's take I to the power 3. Let's start with a small number and we can even move on, right? It doesn't matter how big the index is. So we said the process for simplifying even powers of I is that you first factor out I squared, but that's not the case for odd numbers. For odd numbers, what you factor out first is an I, so that you'll be left with an even number, an I with an even number, which is I squared. Now we know I squared is -1. It therefore means that I squared, this we are going to have I into -1, so I cube is equal to -I. And okay, let's look at now a very big power. Let's consider, maybe let's say I to the power 107. Okay, so this, for we said the procedure first factor out I. So when we factor out I, we have reduced 1 from 107, making it an even number. So we are left with I to the power not 2, 106. I to the power 106. I to the power 106. We go ahead now to apply the method for simplifying even I to the power even powers. I with even power, sorry. So we get I is going to be equal to I that we have factored out into I to the power squared. We said we first factor out squared, and what is left out of the bracket? 53. Because 53 times 2 gives us 106. Now I squared is -1. We copy I squared is -1 to the power 53. Remember, 53 is an odd number. That therefore means this becomes I. So -1 to an odd number is -1 simply. It therefore means I to the power as big as 107 is just simply -I, simplifies to -I. Okay, with these 4 examples, you must have seen that when the index was even, it was always, that is 2n, it was always either a positive or -1, as we earlier saw in the video. And when the index was odd, it was always either a positive or -I. You can do many other examples and the results will always still be the same. Okay, if you're enjoying the video so far, just do well to like, subscribe and share the video. Now so far we have been seeing positive I to the power positive and positive even and odd powers. I to the powers positive and positive even and odd powers. Now let's look at I to a power to a negative index. So how is that done? I told you at the start of the video that with a good foundation, simplification foundation, you won't have a problem. Okay, let's take a look at, let's say maybe I to the power -24. We know that a to the power -n indices is equal to 1 over a to the power n. This simply means that I to -24 is just equal to 1 over I to the power 24. Now I to the power 24, let's focus on the denominator now. I to the power 24 is the same as I squared to the power 12. Yes, and 1 over I squared is -1. 1 over -1 to the power an even number, which is 12, is equal to, so all of this is equal to 1 all over -1 to the power an even number is 1. So that this therefore means that I to the negative 24 is simply just a positive 1. As simple as that. Same goes for same goes for simplifying odd powers. Let's try I to maybe I to negative 20, let's just say 23. So I to negative 23 is same as 1 over I to the power 23. And so we said with odd powers, we first factor out I, and what is left, it will be I to the power 22. So continuing, we get, let's just continue up here. We are going to get 1 over I into I 22 divided by 2. We factor out I squared because 22 is an even number. We get an 11 here, which is an odd number. We proceed. So we have 1 over I into negative 1. I squared is negative 1 to the power 11, and negative 1 to an odd power, as we have been singing since, is negative 1. So we have 1 all over I to the power negative 1, which is equal to negative 1 over I. Or if you want to write it in a more fancy way to show that you are a mathematician, you get negative I to the power negative 1. So that is the simplification for I to the power negative 23. Okay guys, that's it for this video, and see you in the next video.